Okay, this is my first attempt at doing an explain everything explanation, and I want to start with an explanation of imaginary and complex numbers. You would have had this in Algebra 2. It would have been, the idea might have been introduced in Algebra 1, but it begins with the idea of the square root of -1. You may have been told in Algebra 1 that you can't take a square root of -1. And there's a very simple reason, because, well, suppose you do, 1 squared. Well, that equals 1 times 1, which of course equals 1. Well, what if you take -1 and square that? Well, that's the same thing as -1 times -1, and of course a negative times a negative is a what? It's a positive. Well, that also gets you +1. So how in the world can we get a number that multiplied by itself would get us a negative? Well, the answer is that there is no such number, at least in the realm of numbers that we typically call the real numbers. There are a set of numbers called the imaginary numbers. That's not the best name for it, but it needed some kind of name, and there's a whole series of videos which I could point you to, which basically says imaginary numbers do exist. They're weird, but they do exist. So we have this number, and we just call it I for imaginary number. That's what the square root of -1 is. So, well, that gives us the square root of one negative number, but that's all we need. If we just have this kind of basic unit of square roots of negative numbers, of this basic unit called I of imaginary numbers, we can do a square root of any negative number. Take, for example, -4. Well, -4 is the same as -1 times 4. And hopefully what we remember is that we can split these square roots into square root of -1 times square root of 4. Well, square root of -1, as we just said, was I, and square root of 4 is 2. So this will equal 2i. Now this brings back all of the stuff involving square roots that you may have blocked out several years back that you didn't like, and it is back, basically, the idea of reducing radicals, which is something that you will need to know how to do. Okay, so now we're going to have a look, remind ourselves of how to reduce radicals. Let's say you have a number like, get my thing to work right here, a number like square root of 8. Now, we may know that, well, 1 squared is 1, 2 squared is 4, 3 squared is 9. Well, 4 and 9, 8's between those two, so it's got to be somewhere between 2 and 3, but it's not going to be an exact whole number. But there are numbers that go into 8 that can square root. For example, 8 is equal to 2 times 4. Well, the square root of 2 doesn't have a nice square root, but the square root of 4 does. And so that can become a just plain 2. And normally, normally we have this 2. We don't normally write it like that. What we normally do is we normally write it as 2 square root of 2. Basically, we're showing that this 2 on the left here is not under the square root with that 8. So now let's see what happens if we did square root of -8, for example. Okay, let's try that again. Square root of -8. Well, it's much the same thing, except this time we also have a square root of -1 in the mix. So this square root of -1 becomes an I, this square root of 2 stays a square root of 2, this square root of 4 becomes a 2. Now, we're going to remix this thing. It's going to look very similar to our answer down below, is going to be 2 with the square root of 2, but there's going to be an I in between there, and that is 2I square root of 2. Now at any point, of course, you can pause this video if you need to pause to take it all in. For now, I'm going to move on to the next topic, subtopic of imaginary numbers, and this involves what happens if I do, well, if I do different powers of I. So I'm going to do the first several powers of I. It's supposed to be a 4 there. Now let's do the easy ones first. I to the first power. Well, anything to the first power is, well, itself. I squared, well, how do we define I? We defined I as square root of -1, and I squared equals -1. Now, how do I raise to the third power? Well, if I take I squared and multiply by another I, that's going to give me a -I. So I got a notification there. Now, to go to the fourth power, I take that previous result, -I, and multiply it by I also. -I times -I is -I squared. Well, that's the same thing as -1, which is the same thing as +1. Now, let's go backwards. I to the 0 power. Hopefully you remember that anything to the 0 power equals 1. Now, I want to highlight these in different colors here. Let me see if I can do this. Okay, so I to the 0, trying to circle that a little bit better there. Okay, come on, let's do red. I to the 0 equals 1. I to the first equals I to the second equals -1, I to the third equals -I to the fourth equals, that whole process gets us to 1. Notice we started at 1 with I to the 0, and when we get up to I to the fourth, we're back with 1. Now, what happens if we multiply it by I again? Let's do this in white this time. If I can find white, there we go. I to the fifth, well, I take that 1 and multiply it by I. Well, guess what I've got? I've got I again. Okay, I'm going to arrange this a little bit better in the next little screen. I'm going to pause and then delete this and arrange it a little bit better for you, if you just a second. All right, let's have a look at this. Okay, you see I've got my first 4 I to the 0, 1, 2, 3, and you can see I have a 1, and then that's supposed to be an I there. I, and then -1, and then -I. And then when we said I to the fourth equals 1, I to the fifth equals I, what would you guess the next one's going to be? Well, look at the left column. This second column is following the exact same pattern. And I to the eighth, we're back at 1 again. So what we can see is that there is a cycle that this follows. Every 4 powers of I, it goes back and does the same thing. With that in mind, we could figure out what I to the 100th is. How do we know that? Well, because 100 is a multiple of 4. Well, notice these multiples of 4 in this top row are all end up equaling 1. So I to the 100th also equals 1. What about I to the 101 power? Well, since I to the 100th was 1, I to the 101 is just below, is just right after the I to the just after the I to the 100th power. Well, what's that next value? That next value is I. So A way you can do this is take the power and divide it by 4. If it goes in evenly and has a remainder of 0, it is going to be this top number here. So let me write this up here. So this is, if the remainder is 0, it's that top row. If the remainder is 1, it's the second. It's this next row. If the remainder is 2, it's here. If the remainder is 3, that is what the answer will be. So let's take, for example, I raised to the 145th power. It's supposed to be 145th power. Well, if we divide by 145 by 4, well, it goes in, let's see, it goes in 36 times. But 36 times 4 is 144, which means the remainder equals 1. Well, if the remainder is 1, we can see it is this first row up here, which is R1, which the result is just going to be I. Now we're going to do something a little easier. Complex numbers can be written in the form some number plus some number I. And if we're just adding one complex number to another complex number, all we're doing is adding like terms. So this 5 and this 2 will add and give us a 7. This 3 and this negative 4i will add, which gives us a negative 1i, or just a negative I. Fairly straightforward. What if I were subtracting this? So the 5 would subtract, or we'd have 5 minus 2, which is 3. 3i minus, and be careful, minus negative, which gives us what? 3 plus positive 4i. So that's another type of problem that you'll find in this section, which is fairly easy. Next, we'll look at multiplication. So let's have a look at, let's say we have something like 2 plus 3i times 4 minus 5i. Well, if there were variables here, we would just do FOIL, first, adder, inner, last. Our first product is 2 times 4, which is 8. Our outer is 2 times negative 5i, which is negative 10i. Our inner is 3i times 4, which is positive 12i. And our last is going to be 3i times negative 5i, which is negative 15i squared. And then these middle terms here will add. I have 8. Negative 10i plus 12i is positive 2i. And then I have a minus 15i squared. Now, if those i's were just variables, then we would basically be done. We have like a quadratic type situation. But this I squared equals negative 1. So this is 8 plus 2i minus 15 times negative 1. Minus 15 times negative 1 is plus 15. 8 plus 15 is 23. And then the 2i remains the same, and that is what our result is. Now, the next part is a little bit more involved, and I'll do an example like one in the book. I'll do an example that is actually one of your problems, so I'll basically be giving this one away. You're welcome. Dividing. Now, dividing does not work the way at all that you might think it does. What we have to do here is this denominator, I have to multiply by what's called its conjugate. Notice that this is plus, this is minus. The reason why this works is because this denominator will become a real number. Well, whatever we do to the denominator, we also have to do to the multiply by the numerator, and put some parentheses up here. Now, if you recall the way difference of squares worked, this is exactly the difference of squares pattern. If a difference of squares, remember the outer and the inner products will cancel, and so you don't even have to do the whole FOIL. All we have to do is multiply the 4's together, which is 16, multiply the 2i and the negative 2i, which is negative 4i squared, and the outer and inner products cancel, so there really isn't anything left in the denominator. Now, in the numerator, we do have to do the whole FOIL out. So we'll do that. 3 times 4 for the first is 12. Outer, 3 times negative 2i is negative 6i. Negative I times 4 is negative 4i. Negative I times negative, we have a positive then. We have positive 2i squared. Now, we're not done. 16 minus 4i squared. Well, that I squared, remember, is a negative 1. So it's really, we're adding 16 and 4, which equals 20. Now, the numerator. The negative 6i and the negative 4i add and become negative 10i. And the plus 2i squared, well, this I squared also is negative 1. So we're really then subtracting this 2. So we have 12 minus 2 is 10, minus 10i over 20, which then reduces to, if I divide, I can divide both numerator and denominator by 10, 1 minus I over 2. I'll let you can rewind and look at this as many times as you like, but this is the way division works with complex numbers. And I think I'll let that be all for now. That's plenty for my first explain everything lesson. We'll see how this all looks in its final result. Thank you.